So now what I said in our previous class, that I have to estimate alpha values. Okay. So how can I estimate alpha values? So what I said, that I have a sample, present sample, and I have a previous sample, and I said present sample can be estimated from the previous sample using a linear combination with alpha. Alpha 1 into y m minus k. Okay. Okay. So what is the error? Error is the current sample minus estimated sample. So that is the error. So what is mean square error? Mean square is nothing but the En is the mean square error, is nothing but a square of the error for all over m. So I can estimate y1 from y0 and let other value, y2 from y0 y1, y3 for like the y1 y1 y0 y2, like that. I can say p, estimator p. So I can say each time I calculate the error and take the average, take the sum, so I can get the mean square error. So En square. So En square is nothing but a square of this one. Okay. So now I want to minimize the mean square error. So fx is a function. So how do I minimize the function? With respect to what I want to minimize? With respect to, I want those set of alpha value where this En is minimum. So my objective is to find out those set of alpha value for which my error is minimum. So that means I can take the differentiation dEn with respect to d alpha, and that is equal to 0, give me the minimum error condition. So what I will do, I will take the dN divided by d alpha I is equal to 0 for I equal to 1 to p. P is the prediction, number of prediction. So let us say I want to design a predictor of p is equal to 20. That means I can say that the current sample is a linear combination of the previous 20 sample. So there is a 20 alpha 1, alpha 2 dot dot alpha 20. So mean square error expression has to be, take the derivative, has to be, derivative should be 0 to minimize the error with respect to the alpha. So dEn by d alpha I is equal to 0. So I take the derivative of this dEn, En is nothing but a ym minus whole square. Okay. So it is nothing but a, take the derivative means d dx of x square. It is nothing but a d dx of 2x into into d dx of x. Okay or not? So I can say 2 into this one into minus this one. Is it okay or not? Because yn m does not contain any alpha. So d alpha, so d alpha of yn m is equal to 0. So only this part has an alpha, that is why this part is there. Now if you see, what is d alpha of k equal to 1 to p alpha k ym m minus k. So alpha k ym minus k is a constant with respect to d alpha except k equal to I. I am taking the derivative with alpha I. So except this alpha k equal to I, that means that is alpha I. Otherwise it is constant, it is not in his purview. So I can say only alpha k ym k is exist when k equal to I. So I can say this differentiation is nothing but a minus m minus I, because that time the alpha I d alpha I by alpha I will be 1 and m minus I will be exist. Is it clear? I am taken the square, take the derivative. Derivative of x square is nothing but a 2 into x into 2 into x into d dx of x. So now when I say the x is, this one is not, doesn't contain any alpha, so this will be 0, this will be minus this one, but alpha k varies from 1 to p. Now except k equal to I, that others are constant with respect to alpha I. Okay, so that is 0. Derivative of a constant is 0. So I can say this is nothing but a minus m minus I. So I can say final derivative becomes 2 into this one into yn m minus I. Now I can say this is ym into this one is equal to ym into this one. Let us say m is a signal, m is varies from minus infinity to infinity, but k is varies from 1 to p. Is it clear? Now I can say that let us phi ik is defined as this one. This is nothing but a phi n ik. So this is I is there, k is 0. So I can say this side is nothing but a phi I0, phi n I0, and this side is nothing but a alpha k will be there, and this side is nothing but a phi ik. So I can say phi n I0 is equal to k equal to 1 to p alpha k phi n ik. So I also varies from 1 to p. Okay. Now if you see, I have a p equation in p unknown. So I have an alpha 1 to alpha p unknown, and I have an p equation I1 to IP. So I can say phi n 1 0 is equal to k equal to 1 to p alpha k phi n 1 k. Now I can solve it. I can solve it for, so I have a p number of unknown, I have a p number of equation. So if I want to write in matrix form, so this side, how can I write in matrix form? This side what is there? Alpha k, so k equal to 1 to p, so I equal to 1. So if I say 1 phi 1 0, this is I equal to 1. So I put I equal to 1, k equal to 1 to p, so I can say I equal to 1 1, phi n 1 2, 1 3, phi n 1 p, because k varies from 1 to p. Next I equal to 2, so second row 2 1, 2 2, 2 3, 2 p, alpha 2 multiply by alpha 2, phi n 2 0, I equal to 2, I equal to 3, I equal to p. So this is a matrix form of this equation. Now I have to solve this matrix to find out alpha 1 to alpha p. Now can I say this is a symmetric matrix? So what is phi 1 1? So phi 1 1 is nothing but what is phi ik is nothing but a signal y m minus I into signal y m minus k, which is nothing but a covariance of the signal. So that's why it is called covariance matrix. Understand? So this covariance matrix is symmetric but not tripocial. Topolized, it is not that, and can be solved using Cholesky decomposition. So this is a matrix solution. How do I solve this matrix? Okay. So that I get a p number of p set of equation, I have to solve for alpha 1 to alpha p. So there should be some method to solve it. Let us discuss about that methods. Okay. Now before that, What is minimum mean square prediction error? What is minimum mean square prediction error? So, En is equal to this one. I calculate the minimum mean square prediction error. So, a minus b tar whole square, a square minus 2ab plus b square. Summation of m equal to minus m into infinity, a minus b tar whole square. So, let the signal is infinite length. So, a minus b square, a square minus 2ab into b square means 2, this is 1b and this is second b. Okay. So, now it can be solved. So, now what is the, so what is this? So, if I say m equal to minus m into infinity, k equal to 1 to p alpha k yn m minus k, and I equal to 1, L equal to 1 to p alpha L yn m minus L. So, when I say that, then can I not say this one is nothing but a estimation of yn m? So, instead of that, I can put yn m. Minimum mean square error, that means error is 0, let us say considering 0. So, my estimation is correct. So, I can say this is nothing but a ym. So, I can say that this product is nothing but a this product. So, I can say 2 minus 1 of this. So, that is nothing but a y square minus this one. Now, if I want to express in term of phi, is nothing but a phi n 0 0, I equal to 0, k equal to 0 minus k equal to 1 to p alpha k. So, it is nothing but a 0 k, I equal to 0, but k is there. So, that is minimum mean square prediction error. Now, if I say how do I, so minimum, so this is an equation number 2 and this is an equation number, sorry, this is an equation number 2 and this is an equation number, let us 3. So, from these two equations, how do I calculate the value of alpha 1 to alpha p? So, what are the method exist to solve for alpha 1 to alpha p? Let us we describe two methods. First method is called autocorrelation method. And I will give the example of a speech signal. Let us say speech signal. Let us say I have a signal. I cut a signal of a window length of L. So, N is minus infinity to plus infinity, long signal I have. So, I take a signal portion of a signal which is cutting by an window length Wm, which is 1 for 0 to L minus 1, elsewhere it is 0. So, if I say the index of the signal m equal to 0 to L minus 1, if the static index is n, it is nothing but a n plus L. So, in infinite sample space, if the static index is n, it is nothing but a n plus L minus 1. If the static index is 0, so it is m minus L minus 1. So, what I am saying, I have a long signal, I take a portion of the signal which is length L. So, that means index of the signal is varies from 0 to L minus 1. So, finite length window of L sample. Okay. So, now what should be the length of the prediction error? Here is an example. So, I have taken this portion of the signal, let us say this portion of the signal I have taken. So, this is here, this is the portion of the signal. So, outside that signal is 0. Now, what I said, I want to run pth order predictor. So, that means I said current sample can be predicted from the p number of previous sample. So, all the previous samples are 0. So, I can say first sample, let us the first sample can be predicted from the p number of sample whose values are 0. So, I want to predict the first sample from the previous p number of sample whose values are 0. So, what is the prediction error? Is nothing but a sample size, whole or error. So, linear combination of the 0 is nothing but a 0. So, the prediction error will be the maximum, the value is the sample value. Then second sample, I am predicting from first sample and previous p minus 1 number of 0. So, error will be maximum, because all the coefficient is 0, only one coefficient is contributing. So, I can say up to p number of sample the error will be maximum. So, I can say the beginning of the window the error will be maximum. After that I am predicting a sample where the p samples are there. So, the error will be minimum. So, then I get the error. Again when I come to here, I am predicting 0 from the previous p number of sample value. So, the prediction error will be again maximum. So, I can say the length of the prediction. So, it is nothing but a convolution equation. So, it is length of the prediction is nothing but L minus 1 plus p. So, En is nothing but you can say this is a convolution kind of equation. So, I can say length of En is nothing but L minus 1 plus p. Let us say if I told you a real life example, suppose I have a speech signal of 8 kilohertz sampling rate. If I say my window length is 20 seconds, that means how many sample will be there? 160 sample will be there. So, my L is varies from 0 to 160, 160 minus 1, 159. Then if I told you what will be the, if I run a 14th order prediction, then what should be the length of the prediction error? So, length of the prediction error is nothing but a L plus p minus 1. So, 160 plus 14 minus 1. So, it is nothing but a 173. Okay. So, if I cut the signal, the problem is the prediction error in the beginning and the prediction error in the end is maximum. Now, when I say how many sets of alpha I will get if I run 14th order prediction. So, for each sample I get a set of alpha value. So, if there is a 160 sample, I get a 160 set of alpha value. Out of 160 set, I can say my job is to find out the one set which will minimize my error. So, or I can say out of 173 error position, all alphas are there. So, 173 set of alphas are there, alpha 1 to alpha 14, 173 sets are there. Out of 173 set, I have to find out one set for which my error is minimum. So, that is my job. Okay. So, at least I require 14th equation. I require at least 14th En I required, but I will get 173 of En. My job is to find out what is the minimum, which are the set of alpha, find out the optimal value of the set of alpha for which error is minimum. Okay. Then I said, okay, autocorrelation method. So, why this is called autocorrelation method? This yet I am not discussing about the autocorrelation method. I have only said I have a long signal, I have a cut portion of the signal, and using that portion of the signal, I want to find out the value of alpha 1, alpha 2, alpha 3, which will represent that portion of the signal. Okay. So, now you can say that ENM is nothing but a signal minus estimated signal, and signal is only non-zero. So, I can say the error is only non-zero over the interval of 0 to L minus 1 plus P. So, mean square error, I do not have to compute infinite samples, I only compute to m equal to 0 to L minus 1 plus P, because elsewhere it is 0. So, it is not contributing the mean square error. So, mean square error is contributing only L minus 1 plus P number of error. Okay, understand? So, I know that phi ik that we have already derived, phi ik is represented by like this way, where I equal to varies from 1 to P and k also varies from 1 to P. And SNM outside that L minus 1 is 0. SM, the signal is outside that L minus 1 is 0. So, I can say phi ik, so this is the error is contributing only L minus 1 plus P. So, L minus 1 by plus P m equal to 0 to this one. So, when I say phi 1 0 0, so I equal to 0, k equal to 0, it is nothing but m equal to 0 to L minus 1 plus P Sn 0 multiplied by Sn m multiplied by Sn m. So, which is nothing but each sample will be multiplied with each sample up to L minus 1 plus P number of sample and added together. That is nothing but a phi 0 0. So, phi 1 0 1 1, phi 1 2 I can calculate easily. That is nothing but a covariance of that window signal. Now, if you compute it, then when you say that outside the L minus 1 signal is 0. So, if I say here S of m, although it is L minus 1 plus P, but outside the window L minus 1 signal is 0. Let us say I consider m minus I as an m, m minus I as an m. So, now it is becomes L minus 1 plus I. So, I can say that L minus 1 plus I minus k into Sn m plus Sn m plus I minus k. I just change the index. So, I minus k is an absolute value. So, if I equal to 0 and k equal to 1, that value is minus 1. If I take there is some value will be there. Let us say mod of I minus k. So, I can say mod of L minus I minus k non-zero term in the computation of phi I k. So, if I say that I minus k has a value, that means whether it may be a negative, it may be a positive, but it has a value. So, if I take the mod of that part, mod of part as a value a, let us say value is a. So, once I set the value is a or k, whatever I can say that this value is k, let us say. So, it is nothing but a signal S m plus k. So, what is the correlation? Correlation is nothing but a signal R1 is equal to S1 into Sn plus 1, mod n varies from 0 to L minus 1. So, I can say phi ik is nothing but a correlation, autocorrelation. Why it is autocorrelation? Because signal correlate itself. So, it is nothing but a phi ik can be replaced by an autocorrelation value. So, the equation k equal to 1 to p alpha k phi n ik phi n I0 can be replaced by ik can be replaced by Rn I minus k. So, it is nothing but a autocorrelation. And minimum mean square error, again phi can be replaced by a R0 0 and it is nothing but, so this is nothing but a R0k Rk and this is nothing but a R0. So, which is the energy of the signal? Okay. Now, I can say, so I can say R0 if I want to repeat this equation as a matrix form. So, I can say R0, R1, R2, Rn p minus 1, I minus k. So, if I say k equal to 1 to p, so there will be a I minus 1 term will be there. So, if I when it is p minus 1 will be there. So, I can say it is p minus 1, p minus 2, p minus 3 like that, alpha 1, alpha 2, alpha 3, alpha p, and this is R1, R2, R3, Rp. Now, you can see all the diagonal element is same. This matrix, lower triangular matrix, upper triangular matrix is same. Now, this is an tripolar matrix form which is symmetric, all diagonal elements are equal. This matrix can be solved using Levinson and Darwin recursive methods. So, next class I will talk about this recursive method. I will not going details as in mathematics, like the mathematics. You can search in mathematics Levinson recursion, you can get it, but I will show you how this matrix is solved for computation of alpha value and how you can write a program to compute the alpha value if you know the signal Sn. Okay? Thank you.